All right, ladies and gentlemen, welcome back to another Athenian Stranger tutorial video where today we are going to do our 1,000 subscriber special by solving all the questions from test number 5, starting with number 1. Here we go, number 1. Please make sure you're writing this down since I'm writing it down. And please do check out ogmath.com for more examples and notes. Simplify. Ladies and gentlemen, that's ogmath.com, future home of merch. Okay, so simplify 2 to the 3rd power times 2 to the 4th power. All right. We have to apply something called the product rule. Okay, product rule says that if the bases are the same, we just add the exponents. So here I've got the bases are both 2, so I'm just going to add the exponents. I got to write the base. This is key. People are not writing the base. Okay, and then you add the exponents. 3 plus 4. So I have 2 raised to the power of 7.
That was easy.
Okay. Please do not multiply 2 times 2. All right. The most commonly, the most common incorrect answer was 4 to the power of 7. So, okay. So here's what I'm going to do. I'm going to deal with this problem as if it really said 4 times 4 times n squared times n. I'm allowed to reorder the terms like that. I can put them in any order I want. It's all being multiplied, so it's okay. If there was addition or something in there, this wouldn't be possible. Now, if we really want to be clever, we could say this is 4 to the 1st power times 4 to the 1st power. So that's 4 to the 2nd power, 4 to the 1 plus 1, which is 4 squared, okay, times. Now remember, this variable n, it has an exponent of 1, but that exponent is just, it's understood to be there, so it isn't written, but you need to write it until you understand what's going on. And then you're going to apply the product rule, which says if the bases are the same, you add the exponents. So 2 plus 1, that's 3. So now I have 4 squared n cubed. Here's one problem. If I look at my answer choices, that isn't one of them. And so we just need to go ahead and make 4 squared into the number that it represents. So that's 4 times 4 times n cubed. Well, 4 times 4 is 16. So the final answer is 16 n cubed. All of this, each step is equal to the preceding step. Okay? 16 n cubed. Please make sure you're writing this down. All right, ladies and gentlemen, number 3. Moving on to number 3. Simplify. Okay? Simplify. Okay. 2x to the power of 0 times x. One way you could simplify this is by going to ogmath.com and learning the 0 exponent rule so you can do this problem. Because we're going to have to use the 0 exponent rule here in order to solve this problem. Okay, so let's recall. Maybe we should write that over here. Recall that anything raised to the power of 0 equals 1. Okay, big brain time. If a to the power of 0 equals 1, then what about x to the power of 0? Okay, it's also 1. So I'm going to come back in here and replace this x to the power of 0 with a 1. And remember, it's multiplication, so that's 2 times 1 times x. So what's 2 times 1 times x? Okay. We can't add 2 and 1 because it's multiplication. So 2 times 1 is 2. 2 times x is 2x. So basically, this is 2x. Final answer. Number 4, ladies and gentlemen, number 4, coming in here with number 4, simplify r to the negative 4th power, r to the 3rd power. Okay. Now, the first step in simplifying is to hit that subscribe button. Go ahead and hit that subscribe button and turn that little bell on so you're always getting notified when I release new videos. All right, this video is not sponsored, and that's because we don't have enough subscribers. So please hit that subscribe button so I can get a sponsor. All right, ladies and gentlemen, back to the problem. Simplify r to the negative 4th times r cubed. All right, so what we need to do here is we need to use both the product rule and the negative exponent rule. So it might be useful to recall what the negative exponent rule says. Okay? The negative exponent rule states that anything raised to a negative exponent, okay, is equal to 1 over that thing raised to the positive version of that exponent. All right, this seems hard. It seems harder than it is. All right? Well, we'll worry about that in a minute. Remember, first, we're just going to add, right? The bases are the same. So we're going to say r raised to the power of negative 4 plus 3. Okay? Big brain time. Negative 4 plus 3. So I'm at negative 4 plus 1 plus 2 plus 3. I'm still negative. I'm negative 1. Okay, so here equal r raised to the power of negative 1, ladies and gentlemen. So let's bring that over here. Think about this. So the m is a 1. Basically, it's the same situation, right? You apply that negative exponent rule, and you just write this as 1 over r to the first power. Remember, we changed the exponent from a negative to a positive when we put it into the denominator. Well, we don't need to write that 1. Okay, it's just understood. So final answer, 1 over r, ladies and gentlemen, 1 over r. Okay. Number 5, ladies and gentlemen, number 5 coming in hot. Number 5, simplify. Simplify. Simplify what exactly? 4 to the 3rd power over 4 squared. Okay, simplify that. Well, it looks like we're going to have to use yet another exponent rule. This time we're going to be using the quotient rule. So let's remember what that is. The quotient rule. It says a to the m over a to the n equals a to the m minus n. Okay, so if the bases are the same, you subtract the exponents. Well, the bases are the same here. So please remember, ladies and gentlemen, before you do anything else, hit that subscribe button and go to ogmath.com and bookmark it. And then write the base of 4. Remember to write that base. It's all about that base. Write the 4 and then put 3 minus 2. Okay? Well, that's 4 raised to the power of 1, which is just another way of saying 4. Final answer, 4. All right, ladies and gentlemen, number 6 coming up. Number 6 coming up. Here we go, number 6. Simplify. Okay, simplify. N over negative 3n. All right. Now this problem can be easy or this problem can be hard. Let's treat the problem like we're taking math seriously, okay? So remember, when there's no exponent written, we assume there to be a 1 in the exponent section. Okay? Further, and this is perhaps the most critical part for this particular problem. Further, in front of this n, we need to remember that there's a 1. Okay? So if you don't write that in, there's a risk that you're going to not understand what happens next. And here's what's going to happen next. Go to ogmath.com and hit that subscribe button. All right? And after you do that, we'll continue the math problem. And here's what we're going to do. We have 1 over negative 3. We'll deal with that in a second, okay? Because we have a bigger problem on our hands, and that is, what is going on with the n? Well, what you're going to do is you're going to subtract 1 minus 1 like this. So you're basically applying the quotient rule to the variable. And you get, now we don't put negatives in the denominator, so it's just negative 1/3 times n to the power of 0. Okay, well, remember, ladies and gentlemen, that anything raised to the power of 0 is 1. Therefore, we have negative 1/3 times 1. And that means the final answer is negative 1/3. Okay? Number 7 coming up. Number 7 coming up, ladies and gentlemen. This one's getting a little bit harder. Simplify. Simplify. And then we've got 2m to the negative 1 n squared. And then I'm going to use my ruler to draw this straight line. Okay. And we put negative 2n on the bottom. Negative 2n. All right, so this is what we have to deal with. Now, my advice is to reorganize the order of these things. Like I want to group the 2's right above one another, and then there's no other m on the bottom. I want to group the n's together. So I don't know if you understand this, but you can break up this multiplication on the top and the bottom however you want. Okay, so watch what I mean by that. This is all being multiplied, right? So I can break this problem up wherever I want. And so here's how I'm going to choose to break this problem up. I'm going to have 2 over negative 2. So I've broken the problem up, pull those numbers out. Now I've got m to the negative 1, okay? I've pulled that m to the negative 1 out all by itself. Then I've got n squared over n. N squared over n. All right? So it may not be immediately clear that this was even possible, but this is, I mean, it's not necessary. It's just, this helps me. All right, I like to break things into chunks. So instead of having one scary looking problem, I have three very simple problems to deal with. Okay. So here's the thing. I've got 2 over negative 2. And we know that there's no way to put a negative in the denominator. So it's just 2 divided by 2. And the result's going to be negative. Well, 2 divided by 2 is 1. Okay. Anything divided by itself is 1. So it's just negative 1. Wow. Now remember, before you write m to the negative 1, remember out here that m to the negative 1 is going to equal 1 over m. Right? That's that negative exponent rule. So I better write this as 1 over m times. Well, look out here. I've got n to the second power over n to the first power. So I have n to the 2 minus 1, which is just n to the 1, which is just n. Okay, so this down here, we just put n. And now it's time to bring it all together. So we're going to bring it all together. I have negative 1 times n. That's just negative n. And then the only thing that has a denominator is this. So I just write over m. Negative n over m, ladies and gentlemen. Number 8, coming up, number 8. Here we go, number 8. Simplify. And then we've got this scary looking thing, okay? So it always says simplify when it's going to be scary. We have open parentheses, 4 raised to the power of 4 times x close parentheses, the whole thing squared. Okay. And now we need our ruler. Got to draw that big fraction bar. Here we go. And then below that we write x squared. Okay? X squared. Okay. So, what do? Well, we're actually going to apply the power rule, the power of a product rule. Here's what that says. If I have a to the m times whatever, doesn't really matter, b to the n, and I've got that whole thing raised to some power p, then what I do is I distribute multiply the outer exponent times each inner exponent using like the distributive property of multiplication. Okay, so that is the power of a product. Power of a product. Okay. Just so you see what that looks like, that's going to be a to the mp times b to the np. You're just going to multiply. You're going to multiply it together. So that's what you're going to do out here. But the key is you have to remember that there's a 1 there. If you don't remember that 1, I'm going to put it in red just so we're totally clear. That 1 is not written, but it's understood. You have to remember the 1, ladies and gentlemen. Okay, so let's do our next step. We're just going to rewrite everything, but we're going to distribute multiply. So we're going to take 4 and raise that to the power of 4 times 2. See, 4 times 2 times x. raised to the power of 1 times 2. We didn't touch the denominator, okay? So we're just going to write big fraction bar and put that x squared down below, okay? Very good. Well, now we need to simplify this, don't we? We need to simplify this. So we have 4 raised to the power. 4 times 2 is 8. Okay? Times x raised to the power of 1 times 2. Well, last time I checked, let me check my watch. 1 times 2 is 2. Okay, survey says x squared. All right, and we're going to draw a big fraction bar and put x squared down below. So here's the situation at this stage. Now, this should be jumping out at you guys. I got the same thing up here and the same thing down here. Okay? The same bases, we subtract the exponents. So I write 4 to the power of 8, which I'm not going to attempt to like expand that into some big number. I'm just going to leave it in exponential form. And then I'm going to put a times symbol and an x. So I'm going to write that base and then put 2 minus 2. Okay. So let's do a new line. We have 4 to the 8th power. We need to simplify this. 4 to the 8th power times x to the 2 minus 2 is 0, x to the 0 power. And we know, ladies and gentlemen, that the 0 exponent rule states that x to the 0 is just another way of saying 1. So we have equals 4 to the power of 8 times 1, which means our final answer is just 4 to the power of 8. And you know, this problem could have been solved a little bit faster if you start to notice patterns. Okay, so what you've seen me do in many past videos is I haven't applied the quotient rule like I did here. I just said, okay, you got the same thing up here and down here, and you cancel. What I mean by the word cancel is I mean apply the quotient rule and find that the resulting exponent is 0. And then recall the 0 exponent rule and remember that anything raised to the power of 0 is 1. And that all of that, as I actually did that work here for you. Okay, because you need to understand what is going on behind the scenes. Number 9, ladies and gentlemen, number 9, coming in hot, number 9. Number 9, simplify. Simplify. Simplify what exactly? Simplify this. We have 4x inside parentheses. The whole thing raised to the power of 0. Okay, well, this really is going to be a simple problem. If and only if you remember a couple of key things. First, write that 1 in the exponent position of the x. And then remember that the power rule, okay, the power of a product, there's a multiplication sign here. Power of a product states you're going to, we should put a 1 here as well. We're just trying to get this all labeled for you, that we're going to multiply the 0 into every term inside these parentheses. Okay? So let's see what that looks like. We have 4 raised to the power of 1 times 0 times x raised to the power of 1 times 0. Okay? So I can't stress this enough. A lot of people are trying to do these in their heads, and I really understand that, okay? But it really pays in the beginning stages here to write out even this mundane step, which you think you could probably skip. Yes, you probably could skip it, but there will come a time when knowing the pattern is what's going to make the difference between getting it right and wrong. All right, let's simplify. 4 raised to the power of 1 times 0, well, that's just 0. And then x raised to the power of 1 times 0, and that's just 0. Okay? Well, recall that anything raised to the power of 0 is 1. Okay, I keep running into this 0 exponent rule. Okay, so we just replace both of these with 1s. 1 times 1. Well, 1 times 1 is just 1. Okay, so final answer, 1. Number 10 coming up, ladies and gentlemen. Number 10. Here we go. Number 10, getting excited. Simplify. Okay. 2x to the 0 power, and then another parentheses, and then a 3. Okay. Please, please, please. This is so important. All right. In order to get this problem right, the first thing you're going to need to do is hit that subscribe button, hit that thumbs up, leave a comment, and go to ogmath.com. Now we'll get back to the video. The first thing that you're going to have to do is understand that that's 2 times x. So I'm actually going to rewrite this like this. 2 times x to the 0 power raised to the 3. And then I'm going to bring in Mr. Red Pen and put a 1 right there. Okay, so the power of a product rule states that we distribute multiply the outer exponent times any of the inner exponents. Please draw your distribution lines. It makes all the difference, because now we can get rid of the parentheses and just write 2 raised to the power of 1 times 3 times x raised to the power of 0 times 3. Okay? All right, so now we can simplify further. We have 2 raised to the power. Now, 1 times 3, big brain, that's 3. Okay, 3. And then we have x, 0 times 3, that's 0. 1, 0, who's our hero? Well, we remember that in this problem, the hero is going to be that 0 exponent rule, since that just means 1. So we need to do a new line and write 2 raised to the power of 3 times 1. Well, 2 to the 3rd power, or 2 cubed, times 1 is just 2 cubed. Let's see if that's how it is in the answers. Nope, that's not one of the answer choices. So what they want you to do then is to kind of expand that exponential form out into like product form. So instead of 2 cubed, you'll write 2 times 2 times 2. And 2 times 2 is 4. 4 times 2 is 8. Okay, so the final answer is 8. Ladies and gentlemen. Okay. Number 11 coming up, ladies and gentlemen. Number 11. Here we go. Number 11. Moving right along, we're now on the downhill side of this test. Let's simplify. We're doing a lot of that today. Simplify 9 times 6ab. B is to the power of 6, and then 0. Okay. Now, please write this down, okay? Please write this down right after you hit that subscribe button and hit that notification bell. Please give the video a thumbs up and head on over to ogmath.com. hold down Control and hit D on that keyboard to add it to your bookmarks. Let's continue. So here's the thing. Put that 1 there because you're going to need it. You're going to need a lot of 1s, okay? Put a 1 there, put a 1 there. In fact, I'm going to rewrite this, and I'm going to add a whole bunch of more multiplication dots. Here's what I mean. I'm going to write 9 to the 1 times 6 to the 1 times A to the 1 times B to the 6th. And then I'm going to put big parentheses and raise the whole thing to the 0 power. Now, I know what some of you are thinking. You're seeing the pattern here. You're seeing the answer. But please do not rush, okay? I need you to show me that you understand the product or the power of a product rule by distributing the 0 to each term. Okay, so let's go ahead and write it out. You know, this is kind of the thing that students don't want to do. They know the answer because it seems obvious. And that's when you start making mistakes. When you think you know the answer, but really you've got yourself fooled. But if you show all the steps, you reduce the propensity. There's an SAT word. You reduce the propensity for errors. Okay, so here's a pattern. Everything is getting multiplied by 0 in the exponent section. So remember that anything raised to the power of 0, even like if you have some number up there already and it's multiplied by 0, that's going to equal a to the 0, since 0 times anything is 0, and anything raised to the power of 0 is 1. So all of these are 1s. Let's go ahead and write that step. 1 times 1 times 1 times 1. Okay. Now you get to this point and you think, I can't believe this guy's still doing this problem, but let me tell you something. People will look at this and they'll say that the final answer is 4. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. Okay, so the final answer is just 1. It's just 1. The final answer is just 1. Number 12. Number 12. Coming in number 12. Number 12, ladies and gentlemen. Number 12. Oh, this is something new. Finally, something new. It says solve, S-O-L-V-E. Wow. Solve for x. Okay, so it wants us to solve for x. Finally, it wants us to do something. I'm so excited. Okay. And then they give us this enormous parentheses with an x on top, a line, and then a 4, a negative 1. Okay, a lot going on. Close that parentheses up. And then raise the entire thing to the power of 3x. Ooh, looking scary. Getting scared. I'm starting to tremble a little bit, starting to shake. Equals another huge parentheses. And then a 4 over. And then this one is x to the negative 1. Close the parentheses and raise that whole thing to the power of 18. Okay. I admit, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen, workers of the world, I admit that when you first look at this problem, it looks really hard. But just please take it one step at a time, okay? First, we deal with stuff inside the parentheses, and then we deal with the exponents, okay? So let's think about what we've got in the parentheses here. We've got a 1 here in front of this x, and we've got a 1 here. I don't know if that's going to be helpful or not, but I'm just going to put it. Now, I noticed this situation, so I want to examine this situation a little bit more closely. Let's go over here. I've got x over 4 raised to the power of negative 1. So anytime you have a situation like that, okay, where you have the negative exponent in the denominator, what you need to do is move that term up into the numerator. And when you move it, once you move it and you put it up there, you're going to be multiplying it by whatever's up there, like this. And you're going to change that exponent to be positive, okay? I want to draw it again. You got x. This is so important. This is what no one understands. You got x over 4 to the negative 1. And that's equal to 4x. Okay? Like over 1. You know, but we just write 4x. Okay? Again. You've got x over 4 to the negative 1. Bring this sucker upstairs and change that to a positive exponent and multiply it. So I've got 4 to the power of positive 1 times x, which equals 4x. That's how I'm getting 4x when I do this, okay? So on my second line, I'm going to write a new line here. I'm going to write open parentheses, 4x, close parentheses, raised to the power of 3x equals, all right? Now, I hope I can erase this over here. I hope you understand the concept of how we move things from the denominator into the numerator if the exponent is negative, okay? That's what gives us that permission. So now let's look over here inside this parentheses over in side work. We got 4 over x to the negative 1. Okay, guys, please follow the pattern. Just move this sucker up here, change a positive exponent, and multiply it by whatever's upstairs. So look what's happening. We've got 4 upstairs already. We're going to multiply it by this denominator, and we're going to make it to that positive exponent. So 4 times x to the first, this is starting to look familiar. That's just 4x. And so take a look at this. Take a look at this. Over here, I've got 4x in the parentheses. See, that's what this is 4x. This is also 4x, okay? And this is raised to the power of 18. Now, having done that, you should notice something. And I've asked many students today to tell me, look at the inside of the parentheses and describe what you see. Tell me what you see. What you should say is, you should say they are the same. These are the same, okay? 4x equals 4x. Okay, those things are the same. And so here's what that means. This is the logarithmic exponent rule. We're not going to go through the entire rule. What it basically means is we can cancel these and we can set the exponents equal to each other. Like we have now 3x equals 18. Okay? If you're interested in learning more about the logarithmic exponent rule and just how and why it is the way it is, head on over to ogmath.com and look at the worked examples there. Okay, so now in order to get x by itself, we just have to solve this single variable equation for x. And the way we do that is we divide both sides by the x coefficient. The x coefficient in this case is 3, so we're going to divide both sides by 3. These 3's cancel, and we have x equals 18 divided by 3. That's just a math fact. 18 divided by 3 is 6. So final answer, x equals 6. X equals 6. Who's there? Number 13 is here, and here he is, number 13. Number 13. We have another question about simplifying. Simplify And then we've got 4 squared times 4 times 4 to the power of 0 times 4 to the power of -2 times 4 to the power of -1. All right? Well, there's only one little thing, and that is we need to add a 1 right here. And then we can actually just proceed. All right? All we have to do is apply the product property of exponents. Okay? Apply the product property of exponents. What that means is because all these bases are the same, see they're all 4s, then we can just write 1 4 like this as a base and add all this up. And we're going to write it like this. 2 plus 1 plus 0 plus -2 plus -1. Okay? So that's actually the problem we have to solve. Let's do it together. Okay? So 2 plus 1 is 3. 3 plus 0 is 3. 3 plus -2 is 1. 1 plus -1 is 0. So I have 4 to the 0. Recalling that anything to the power of 0 equals 1, then 4 to the 0 equals 1. Final answer, 1. Now 14, 14, 14. Here's 14. We've got 14. Simplify. And then we have x squared. And that whole thing is raised to the power of 1/2. And then we have a fraction bar, which we better draw with a ruler. Underneath we have big parentheses and then an x raised to the power of 1/2. Close parentheses. The whole thing squared. And then off to the right, a lot of people forgot this, there's a big -1. Okay, so it just wants us to simplify. Okay, no problem, bruh. All I need to do is multiply the outer exponent by the inner exponent. This is just the power rule, okay? So we're just going to multiply these things. Well, let's write equals x raised to the power of 2 over 1. I've just written 2 as 2 over 1 times 1 over 2. Okay. Then I'll draw that fraction bar. Then I have x raised to the power of 1 over 2 times 2 over 1. And then don't forget that it's big -1 out here. Okay? We're just taking our time. Now we put another equal sign. And we have x on top. Let's see what this is. Like, let's actually do this. We got multiply across the top. We got 2 times 1 is 2. Multiply across the bottom. 1 times 2 is 2. Well, 2 over 2 reduces down to 1 over 1, which is just 1. So the exponent is just 1. All right, we'll draw that fraction bar again. Okay, things are getting simpler. We're really simplifying. Okay, so here we have 1 times 2 is 2 over 2 times 1 is 2, which is 1 over 1, which is just 1. Okay, so down in the bottom, I also have x to the 1. Now, don't forget that big minus sign and the 1. So we're getting close. We're getting simpler. Now, technically, here's what you're supposed to do. You've got x to the 1 over x to the 1. Well, that's equal to x to the 1 minus 1. Remember, quotient rule says bases are same, subtract the exponents. Well, that is x to the power of 0, which is just 1. So this is the big important thing to understand. X to the 1 over X to the 1 is just 1. Anything divided by itself is 1. So penultimate step, another SAT word there, penultimate. Now, we have to do 1 minus 1. Ladies and gentlemen, hardest problem of the night. 1 minus 1 is 0. So this thing right here, this reduces and simplifies to 0. All right, final answer to number 14 is 0. Number 15 coming up. Number 15 coming up, ladies and gentlemen. Number 15, here we are. Number 15, we have n squared times 4 n to the power of 0 times 2 raised to the power of negative 3 times n raised to the power of negative 2. Okay? Now, before you get all bent out of shape about this problem, just group the terms. So let's group term. Remember, with multiplication, you can group terms however you want. So let's gather the kind of the n's together like this. So first, I'm going to pull the numbers out. Like I'm going to put 4 times 2 to the negative 3 over here kind of off by itself. And then I'm going to put times, and here's where I'm going to get into this, n squared times n to the 0 times n to the negative 2. Now this is going to make it a little bit more obvious what our task is. Okay. You group these together kind of in your head and you apply the product rule, right? So often side work we can say, well, actually we don't need side work. We'll just do it on a new line. We've got 4 times 2 to the negative 3 times n. They're all the same base, so I just add the exponents, 2 plus 0 plus negative 2. All right, so that equals 4 times 2 to the negative 3. We still haven't messed with those numbers. Times n. 2 plus 0 is 2. 2 plus negative 2 is 0. Oh, n to the 0. So remember that n to the 0 equals 1. All right, so at least we got rid of that. We got this equals 4 times 2 to the negative 3 times 1. Okay, now here's something that may not at first seem obvious. I want to write 4 as a number with 2 as a base and some exponent. Okay? Can you think of a way to write it that way? Well, that exponent would need to be 2. Like 4 is equal to 2 squared, right? Think about it, because that's 2 times 2, and that equals 4. Okay, see how that works? You got the exponents of 1, you add them together. 2 to the 1 plus 1 is 2 squared. So I can write 4 as 2 squared. So that's what I'm going to do now. I'm going to write 4 as 2 squared. We're going to write 2 squared, and then times 2 to the negative 3. We can just drop the 1, okay? Well, now guess what? We've got a situation where, look, focus in here, people. The bases are the same, and we can just add the exponents. So I can write final answer 2, that's the base, raised to the power of 2 minus 3. Okay, well, 2 minus 3 is negative 1. Right? So here's that penultimate step, the step before the final step. We've got 2 raised to the power of negative 1. Well, remember, okay, you've got 2 raised to the power of negative 1. The negative exponent rule says that's 1 over 2. Well, guess what? That's the answer. The answer is 1 over 2. So final answer to number 15 is 1/2, or 1/2. 16. Number 16. Here we go. Number 16. This one looks so scary, but it really just isn't. We're asked to simplify, and then they give us 3cb, and that b has an exponent of 0, a squared. Then there's a dot here, and 2b cubed, b to the 3, and then a dot times c. Okay, we need that protractor or that ruler, straight edge, to draw a big fraction bar here. And then underneath that we have 2ab squared times c times 3. And at first, it looks like you've got yourself a massively difficult problem. I agree. But if you just rearrange the letters and the numbers so that the numbers that correspond to one another are grouped together and the letters that correspond to one another are grouped together, this thing just gets very simple, okay? So notice that I've got a 3 here and a 3 here. Well, I'm just going to remember, all this stuff is being multiplied, even the stuff without dots. So I can reorder this however I choose to. Well, I choose to reorder this like this, 3/3. Remember, bite-sized chunks. We don't going to eat this whole elephant all at once. So now I took care of the 3's. Now see these 2's here? 3/3 times 2/2. Now I took care of the 2's. Now let's look at the A's. Like, let's go ABC. Let's go in alphabetical order. So I got, up here I've got a squared, and down here I've got a. So up here I got a squared, and down here I've got a. Now let's deal with the B's. Okay, I got a couple of B's upstairs. I got b to the 0 times b cubed over b squared. Okay. Now let's look at the C's. Upstairs I've got a C times a C, C times C, and then downstairs I've got 1C. Okay. All right, so we're just moving right along, folks. All right, so I hope at this point you know that 3/3 is 1 and 2/2 is 1. The way that we would do that is we would write cancel, 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 cancel. This is all just a bunch of 1's, so we can just safely kind of cancel it, ignore it. It's not necessary. It's all gone. So here, let's deal with this. So remember, we've got an exponent of 1 right there. So we're going to apply the quotient rule to that a. We'll have a raised to the power of 2 minus 1. Okay, times. Now check this out. We got b to the 0. Well, little side fact, b to the 0 equals 1. So we can kind of cancel that or ignore that. And now we've got b cubed over b squared. So we'll apply the quotient rule here, b to the 3 minus 2 times. Well, here's another little side piece. We've got c to the 1 times c to the 1. That's equal to c to the 2. So that's c squared over c, right? C to the first. So my final step over here will be c to the 2 minus 1, okay? 2 minus 1. All right, well, let's just continue to simplify. Equals a, now 2 minus 1 is 1, so I've got a to the 1, times b, 3 minus 2 is 1, times c, 2 minus 1 is 1. So a to the 1 times b to the 1 times c to the 1. We don't need to write those ones, so we just write a times b times c, and we don't even need to write the dots. We just write a, b, c. So that whole thing up here simplified down to ABC. Okay, now you know your ABCs. Next time, go to ogmath.com. 17. Here we go, 17. Number 17. We're going to simplify something. Simplify. Number 17 says simplify, open parentheses, and then we're given a squared, b cubed, c to the fourth. Close the parentheses, raise the whole thing to the power of 0. Okay, they want us to simplify it. Guys, remember, the power rule states, okay, the power of a product rule states that you're going to distribute, multiply that 0 to every term, every exponential term. Okay, so let's get rid of the parentheses now, and we'll write a to the 2 times 0 times b to the 3 times 0 times c to the 4 times 0. Okay, big brain. 2 times 0, 0. 3 times 0, 0. 4 times 0, 0. So we have a to the 0 times b to the 0 times c to the 0. Bruh. Okay, so remember that anything raised to the power of 0 is 1. So this is really 1 times 1 times 1. Oh, lordy, lordy. It's 1 times 1 times 1 is 1. Ladies and gentlemen, so this thing simplified to 1. And if you know your power rule, you've got whatever's inside, bunch of stuff. The whole thing is raised to the power of 0. You know that you're going to distribute that 0 to every single term. And so you know everything will be 1. You could have just looked at this. You said, I've got blob raised to the 0 power. The whole thing is 1. The answer is 1. You could have done it in a second. And that comes with time. 18. It's 18 time. 18. Here we go. Number 18. Number 18. Solve. All right. We're excited. We're going to get to solve for something. Solve for what? Solve for x. Given. Well, they're going to give us something. What are they going to give us? Uh-oh. 1 to the power of x. I'm not liking the gift here. No returns. So open parentheses, 6, raised to the power of a, and the whole thing is raised to the power of 4. But wait, there's more. It's like an infomercial. You get more. We get this huge parentheses, and 1 over 6 squared. Close that huge parentheses. The whole thing raised to the power of 2a. And they want us to solve for x. Are they crazy? No. No, we're going to solve for x, all right. We got 1 to the power of x equals. Now, just remember, we're going to take this one piece at a time. We're going to remember our power rule and multiply that 4 times that a. Okay, so we write the base, 6 raised to the power of 4 times a, which is just 4a. Let's go ahead and put that in parentheses so we don't mix it up with what's coming next. Now, the next thing, we're going to distribute, multiply this entire exponent to each of the exponents here. So this one has an exponent of 1, and this one has an exponent of 2. This is the power of a quotient rule, all right? So the power of a quotient rule says a to the m over a to the n, the whole thing raised to the power p, equals a to the mp over a to the np. Okay. So we look here and the pattern is just distribute, multiply the exponent. So on top we've got 1 to the 1 times 2a over 6 to the 2 times 2a. All right. Well, we're going to do some more simplification. We write 1 to the power of x equals. And then we have 6 raised to the power of 4a times. Now, 1 raised to the power of 1 times 2a, that's 1 raised to the power of 2a. Okay? Over And then down here we have 6 raised to the power of 2 times 2a, which is 4a. Okay? Now here's the key. This is the key. Any 1 raised to the power of anything, like 1 raised to the power of 2a equals 1. You could think about it like this. Let's plug in some huge number. 2 times, let's make a be 1 million, okay? So that's 1 raised to the power of 2 million. So that's 1 times 1 times 1 times 1, 2 million times. Guess what the answer is? It's going to be 1. Okay? So that kind of gives this game away. 1 raised to the power of anything is 1. So just play along. Okay, so basically we got 1 to the x equals 6 to the 4a, we didn't touch that, times 1 over 6 to the 4a. Okay. Well, if I put a line underneath this one and put a 1 down here, you can see I'm going to multiply across the top and across the bottom. Well, I have 1 raised to the power of x equals. Now I've got 6 to the 4a over 6 to the 4a. Well, those are the same thing. And so just like we've been doing all day, if we have the same thing over itself, it just cancels out and there's just a big 1 left behind. So here's the thing. I've got now 1 to the x power equals 1 to the 1 power. And I can now use the logarithmic exponent rule. I have the bases are the same. I set the exponents equal to each other. Final step, x equals 1. And of course, it had to. It had to, didn't it? All right, so that was definitely an intellectual mountain that we just climbed. Very good. Number 19. Okay, we're almost done. Number 19, we just have this one and one more. Number 19, oh dear, solve. Okay, at least we're going to solve something this time, like a detective. Open parentheses, 9 times 2 raised to the 3rd power, close those parentheses, raised to the 2x equals, open parentheses, 3 to the 2 power times 8, the whole thing raised to the power of 2. Okay, now the key to this problem is to remember that you deal with the inside of the parentheses first. Okay? So here's what I want you to do. Write it like this. 9 times. Now what is 2 cubed? That's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 9 times 8, the whole thing raised to the power of 2x. Okay. 3 times 3 is 9. So 3 squared is 9 times 8. The whole thing raised to the power of 2. Okay, well, what is 9 times 8? What is 9 times 8? 9 times 8 is 72. So we've got 72 raised to the power of 2x. And over here we've got 72 raised to the power of 2. Now notice, we've got the same bases on either side of the equal sign. In this case, we got a base of 72, and here we got a base of 72. Logarithmic exponent rule says I can cancel those bases and set the exponents equal to each other. So I've got 2x equals 2. So I actually only have to solve this little tiny problem. Divide both sides by the coefficient of the x variable, which in this case is 2. Cancel, cancel, and x equals the quotient of 2 and 2, which is 1. Once again, ladies and gentlemen, x equals 1. If you learn anything tonight, you learn that sometimes a super complicated looking problem can result in a very simple answer. It's number 20, ladies and gentlemen. We've reached the end. Number 20. Oh my goodness. And they give us a book. Okay, here's this whole thing. What values of y make the equation x to the y squared. Wow. So you've got x raised to the power of y raised to the power of 2 equals x raised to the power of 25. And then the final part of the sentence is true, question mark. So what values, okay, could be multiple values of y make the equation x raised to the power of y squared equals x raised to the power of 25 true? So let me just say this. What this problem is saying essentially is solve for y, okay? And if you want to know why you solve for y, head on over to ogmath.com. And on your way there, hit that notification bell and smash that like button. All right, guys. So let's go ahead and solve this for y so we can be done with this test. Ladies and gentlemen, notice right away that this is a red herring. Okay, that means they're trying to lead you down the path of confusion. So you've got letters raised to letters, but the main thing to recognize is the bases are the same. All right, the bases are the same. Now, logarithmic exponent rule says when the bases are the same, you can just cancel them out and set those exponents equal to each other. So I have y squared equals 25. Now, this takes a little bit of thought. Y squared equals 25. How do I get rid of, okay, how do I get rid of the squared? And the key is to take the square root, all right? So final step here is you're going to take the square root of both sides. And the square root of y squared is just y. Okay, so it's the square root of y squared, it's just y. And then on the right side, we have to remember that whenever we take the square root of a number, we have to write plus or minus. Now, what is the square root of 25? The square root of 25, two numbers, the same number multiplied by itself equals 25. That's 5. So the square root of 25, or the second root of 25, is 5, plus or minus 5. So we actually have two answers. We have y1 equals positive 5, and y2 equals negative 5. And you know, there's a reason we don't know which one of these is correct. That's because if you take 5 times 5, you'll get 25. Problem is, if you take negative 5 times negative 5, you'll have a negative times a negative, which is a positive. So 5 times 5, this also equals 25. So we don't know whether the original number was negative 5 or positive 5, so we write both answers. So it was y equals plus or minus 5, or y1 equals 5 and y2 equals negative 5. And ladies and gentlemen, with that, we have come to the end of this whole test. It's done, ladies and gentlemen. We are finished.